Murphy, current AP chemistry student and science expert. Today, we're going to be talking about a chemical called bisphenol A, or BPA for short. Now, you may not know it, but BPA is everywhere, from your water bottles to your safety goggles. This is BPA on a molecular scale. BPA's molecular structure consists of two phenol groups, the carbon rings attached to the hydroxide, and is a nonpolar molecule. Because of its structure, BPA is used commonly in polycarbonate plastics and epoxy resins. But what is it about BPA that makes it so useful? And what makes it potentially dangerous? To find out, I visited professional chemist Roald Hoffman.
Hello, I am on the beach. My name is Dr. Roald Hoffman. I am professional chemist with European accent. You may recognize me from my 1990 hit show, The World of Chemistry. Well, BPA's structure makes it ideal for creating polymers since it has two functional phenol groups, one on each end of the molecule. That means both ends can potentially bond with another monomer, forming the metaphorical links in the polymer chain.
Wow, how interesting. BPA is useful as a component in plastics and epoxy resins because under normal conditions it's mostly non-reactive. It's a solid at room temperature and has a melting point much higher than the boiling point of water. It's also mostly insoluble. But what about its structure and intermolecular forces make it so useful?
Well, BPA's ability to bond on two sites within its molecule makes it excellent for forming polymers. It can also form ester bonds with itself, which creates branching within polycarbonate chains that makes the plastic harder and more impact resistant. BPA's two highly electronegative functional groups exert strong dipole-dipole forces with other molecules. BPA's molar mass is relatively high, at 2 to 8 grams per mole. It has strong dispersion forces, which is important in polymer chains, since hydrocarbons bind together through dispersion forces.
So, BPA has two intermolecular forces going for it, dipole-dipole and dispersion. But some people are concerned about the safety of bisphenol A. For more, we turn to consumer health advocate Bert Warren. Well, right. The concern about BPA is that it escapes from those plastic or epoxy coatings into things like food, baby formula, drinks, and the reason that it can leach or escape from those long polymer chains is because of its molecular structure. Now, because the two ends of BPA are so electronegative, they can actually become slightly soluble in water under extreme heat or being washed in strong detergent. Now, good thing we don't have any of those things in modern life. Oh wait, we have microwaves and dishwashers, both of which can break down the bonds in polycarbonates and epoxy resins, leaching BPA into our food. That means we might be consuming significant amounts of BPA without ever knowing it. But what's wrong with eating a little BPA now and again? Now, a lot of people ask me the question, what's the big deal? What's the problem with eating a bit of BPA, bisphenol A now and again? And, well, sirs and madams, I will tell you the problem. The problem is that BPA is an endocrine disruptor. So basically what that means is it goes, when it enters your body, it goes in and it makes your endocrine system go crazy. Now, I brought my handy dandy clipboard, whiteboard along to illustrate this point. So here is BPA and here is estrogen. So you can kind of see the similarities in their structures. Not too similar, mind you, but similar enough that BPA makes your body think that it's getting a much higher, that it has a much higher level of estrogen in it than it actually does. And the problem There's numerous problems that could be associated with the endocrine system not working well. The endocrine system is in charge of hormones and development. There's been numerous animal studies indicating that consumption of even low levels of bisphenol A can disrupt neurological and physical development in infants and children. Other studies suggest a connection between BPA consumption and an increased risk for cancer, diabetes, and obesity, among other things. Wow! So the same thing that makes BPA so useful, its polar and electronegative ends, are also what makes it harmful to humans. Take this red rose. So beautiful and delicate, yet it could stab me with one of its thorns. In the same way, scientific advancements can do tremendous good, but they can also be dangerous. We must be wary, lest our scientific knowledge bring about our demise. Well, that's all the time we have. Until next week, stay sciencey, my friends, and keep watching Science and Friends.